On to page 14, so the final KP question in the pack. It's a sample exam question. And the confusing part here is the ratio in which they're reacting. So the information that we're given is that they're mixed in a 2-to-1 ratio. But they also react in a 2-to-1 ratio. So we've got twice as much SO2 as we have oxygen at the start. Now a nice way to illustrate this, rather than using chemicals, is to think about maybe making a sandwich, because the slices of bread and the slices of cheese in this particular sandwich are reacting in a 2-to-1 ratio. And if we're starting off with twice as much bread as we have cheese, so let's just keep the numbers nice and easy. So let's say we have 100 pieces of bread and 50 slices of cheese. And let's say we want to make 20 sandwiches. So if we make 20 sandwiches, then that's going to involve 40 pieces of bread, so the amount of bread goes down to 60, but in 20 sandwiches that will just be 20 pieces of cheese, so there'll be 30 pieces of cheese left. So they're reacting in a 2-to-1 ratio. As we can see, they therefore remain in a 2-to-1 ratio. Let's make another 10 sandwiches. So the bread will go down by 20, which leaves us with 40 pieces of bread. The cheese will go down 10, and they're still going to be in this 2-to-1 ratio. So what was the point of that? Well, going back to the chemistry, if we know that at equilibrium we have 0.7 moles of SO3, the mole fraction is 0.7, that means that 0.3 must be for the SO2 and oxygen combined. Now we know that they're reacting in a 2-to-1 ratio, so 2/3 of that will be the SO2 and just 1/3 of that will be the oxygen. So those are our mole fractions. To get our partial pressures, we just want to times those mole fractions by the total pressure. The total pressure was 2 megapascals, so for sulfur dioxide that's going to be 0.2 times 2, which is close to 0.4. For the oxygen we've got 0.1 times 2, and for the SO3 we've got 0.7 times 2, so that's 1.4. So nearly there, our Kp expression now. So we've got partial pressure of SO3 squared over the partial pressure of SO2 squared times the partial pressure of oxygen. We'll just pop those numbers in now. So that was 1.4 squared over 0.4 squared times 0.2, and I got 61.25 for that. Looking at the sig figs in the question, probably sensible to go to 2 sig figs, so we'll leave that as 61. And then finally the units, and we're in megapascals, so with megapascals squared over megapascals squared multiplied by megapascals, or megapascals to the 3, which leaves us with 1 over megapascals, so megapascals to the -1.